So we're given an example, x squared plus y squared equals 1, and we want to use implicit differentiation to find the second derivative of y with respect to x. And so we're going to go through here. We're going to take the derivative of both sides. So d dx, we do something on one side of the equation, we do it to the other. X squared plus y squared is equal to the derivative of the other side, derivative of 1. So looking at the left-hand side, taking the derivative of x squared, well, that is just 2x, plus the derivative of y squared is 2y, but we took the derivative with respect to y, so that's where we put the derivative dy dx, derivative of the inside, is equal to the derivative of a constant is 0. So let's, in this case, solve for dy dx. So let's subtract 2x on both sides, and then we would divide by 2y. So we would get dy dx is equal to subtracting 2x, then divide by 2y. So we get the first derivative is equal to negative x over y. So we want to take the second derivative. So taking the derivative of the first derivative is our second derivative. But when we take the derivative of the right-hand side, this negative xy, we're going to have to use the quotient rule. So the second derivative, we need to take the derivative of our numerator, which is negative 1, times the denominator, which is y, minus the numerator, negative x, times the derivative of our denominator. Derivative of y is 1, but that was in terms of y, so we write dy dx. All over the denominator squared, y squared. So we have negative y plus x dy dx. All over y squared. They said in the directions that they wanted this in just in terms of x and y. And so we actually have to go back in here and we need to figure out or plug in what dy dx is, the first derivative. We found the first derivative to be negative x over y. And so let's do that. If we go back in and plug in negative x over y for dy dx, we get the second derivative is negative y plus x all times the first derivative, which was negative x over y, all divided by y squared. So we get negative y minus x squared over y all over y squared. Let's get rid of the complex fractions, and we can do that by multiplying both the numerator and denominator by y. We distribute that, we get back, this is equal to negative y squared minus x squared all over y squared times y is y cubed. Which is the same thing we had done when we did not isolate dy dx first, and we just went through and did implicit differentiation twice.